Welcome to another tutorial in Ansys Workbench. In this tutorial, we are going to perform a stress and deflection analysis of a simple 2D truss. The truss is made of 5 members as shown. The members are made of steel or aluminum and all have different cross sections as shown. The truss is loaded with a single point force of 1,000 pounds in the minus Y direction and 200 pounds in the plus X direction. The lengths of the beams are indicated in parentheses, where the length of this beam is 3 meters, the length of this beam is 4 meters. In this tutorial, we're going to learn how to build beam cross sections, apply different materials to the same model, and couple beams together that are not in the same direction. I hope you enjoy the tutorial. After opening Ansys Workbench, I'll come up to File, click Save As, and save this file as 2D Truss. The dimensions in this model are given in terms of meters. The default units are millimeters, so I'll just need to make sure that I do a meter to millimeter conversion, or I could go change the units. Then I need to come to the toolbox and open an analysis system. So I'll click the plus to drop down the window, and I'll click on static structural, drag it into the project schematic up to the green box. It'll turn red, and I let go of the left mouse button. I now have my static structural toolbox window. I know I need to add aluminum. The default material is structural steel, so it's already added. So I will double click on engineering data to open up the engineering data box. Now I have my structural steel loaded here, and I can see the material properties associated with it. I want to add aluminum, so I'll go to engineering data sources, and I'll come down and I will click on general materials. So I'll double click general materials. It opens up a bunch of materials that are in a library that I'm able to choose from. I'll scroll up over here until I find aluminum alloy. I'll click on aluminum alloy, and then I'll click the plus sign. The little book shows up here indicating that aluminum alloy has been added. I can now come up and click on engineering data sources again to go back to just the engineering data, and I can see that aluminum has been added. If I want to check the values of the aluminum material properties, I can click on aluminum and I can come down and see the properties here. I can now close out of engineering data by clicking on the X. I'm ready to develop my geometry, so I will double click on geometry to open space claim. I can see down here in the corner that it says starting space claim. After opening space claim, the first thing I like to do is change my sketch plane. The default sketch plane in Ansys Mechanical is the XY plane. So I come over to my structure and right click and then select new sketch plane, and now I can move and my cursor around and see all the sketch planes that are available, and I click on the XY plane. I can now reorient this plane and look down the Z-axis by coming down and clicking on the Z in the corner. I can now control middle mouse button to move my sketch up. To begin drawing, I come up to the line tool and click on the line tool. I will left click on the origin and let go, and I can draw my line. My line is being drawn in terms of a magnitude and an angle. I like to draw lines in terms of components, so I'll come over to the options for the sketch and scroll up and down until I find the Cartesian dimensions and click on Cartesian dimensions. And now my dimensions are given in terms of X and Y components. I can hold my line in the vertical direction and type in a 0 and then tab and type in 3000. and that gives me my first vertical line. I can now move my cursor over and type in 4,000 tab, and I'll leave the 0, enter, and now I can come down and type in a -1,000 tab and a -2,000, enter. And I have one more line to draw, and it connects me back to my 0, so all I need to do is move my cursor down to the 0 and click. Now I have all my outside lines. I have one internal line to draw, so I can come up to escape so that I don't draw the line from the origin. I still have my plus sign indicating that I'm drawing lines. I come and I hover over the intersection until I see the sphere, and then I click on that and I can drag my line down to this intersection sphere, and when I see the sphere I can let go, and I now have my truss, all the members of my truss put together. I can hit escape twice and I'm out of line mode, and I'm ready to reorient my structure. So after reorienting my structure, I'm ready to build my cross sections. So I come along the top menu to prepare. Then I come over to profiles. I click on profiles. I have a solid square, so I come down and click on the solid square. I come back up to the drop down and I have a circular solid, so I click on the solid circular. Now I have a rectangular tube, a square tube, so I come and drop down to a square tube. I now have a hollow circular, so I hit the drop down again and hit solid circular, and then I have one more solid, and I have a solid circular cross section. I can see that all of these beam profiles have been built by coming over to the left and clicking on beam profiles, and I see that each of the different profiles has been put in as a placeholder. I am now ready to put in the details of these different beam profiles. So I left click on the profile, and then right click on edit beam profile. It brings up a new window down here, and I can come and click on the base dimension, and the base dimension will be 0.1 meters, so 100 millimeters. The height will be the same, so I'll click on the blue 10 and type in 100. I have now defined that cross section. I can come back to the design tab down here in the bottom, click on structure, go to beam profiles, and now I can go to circle, then right click, edit beam profile, and then come over, click on ruler dimension, click on the blue 10 and type in 100 millimeters for the radius of my circle. Click enter, and now I can see that I can come back down here to design, back to structure, click on beam profiles. Now I'm going to enter in my rectangular tube, so I left click on rectangular tube, then right click, edit beam profile, and now I need to enter in all of these dimensions. So the W1 dimension is this dimension down here. That's actually for us 120 millimeters, so I'll enter in 120, enter. Our W2 dimension is this dimension right here, which is also 120. So ruler dimension, click on the 100 and enter 120, enter. The thickness, all the thicknesses will be 0.02, so 20 millimeters. So I'll just click on ruler dimension, click the 10, type in 20, enter. Click on ruler, click the 10, 20, enter. Again, click on ruler, dimension, click on the 10, 20, enter. And the last width click on the 10, 20, enter. So I now have defined that cross section, and I can use my middle roll button to zoom in and zoom out to look at the dimensions and make sure that I have it correctly labeled. I come back to design, click on structure, click the arrow to look at all of my beam profiles. I'm ready to enter in my circular tube, so I left click on circular tube, then right click, then click edit beam profile. The outside radius is 120, so I'll click on the 20 and type in 120, enter. Then for the inside, it's 100, so I'll click on the 10, enter 100, enter. And again, I can use my middle mouse button to scroll in and out and make sure that my circle, my hollow circular tubing looks like it should. I have one more, so I'll click on design, structure, open the beam profiles drop down, click on circle 2, right click, then left click edit beam profile, and this is a circular solid with a diameter of 50 millimeters. So click on the 10, type in 50, enter. And I have now built all my beam profiles. You can see that I could scroll through them and check each one of them down here in my window if I want to. Or I can come back to design and look at them and make sure they're all listed here. The next step now is to turn these curves up here that I created as lines into beams. To do that, I come up to prepare and then I click on create, and then I just go click on each line, and you can see that now I have a drop down over here called beams, and I'll have one beam in there, and this line came from the curves and was turned into a beam. When I click on this one, I'll lose another line and I get a beam. And so now I have all of my beams in my, once I have created my beams and got my cross sections with the proper dimensions, I can come back and open up my beams and open up my beam profiles, and now I need to change these. To change these, I come back and click on the design tab, click on the beam, and then I scroll down to that beam, and where it says profile name, I can click on that box and click again to open the drop down, and this will actually be the square rectangular solid to begin with. Then I come back up on my next beam, I click on the profile name, click the drop down. This one's my circular solid, so I click on the first circle, come back up to my third beam. My third beam is my square tubing, so I can come here and click on my rectangular tube. My fourth beam up here is my hollow circular tubing, so I can click on the circular tubing and click that. Then I can come back up to my other beam, my last beam, and click on its profile name as given by circular solid 2. So I now have all of these beams with the proper cross. The last thing I need to do before going into Ansys Mechanical is I need to tell Ansys that all of these beams are connected to each other with a rigid connection. To do that, I come over to the beams in the structure tree, click on the first one, shift click the last beam, and that selects them all, right click and say move to new component. And it has now moved these beams into a new component. I can change the name of that component, or I don't need to. What I need to do though is come down here, and where it says share topology none, right now that says that all these beams would act as independent beams and they are not connected to each other at all. So I need to left click on this box, click to get the drop down, and put merge, or group. I typically use merge, and now I'm ready to save this file and go into Ansys Mechanical. So to enter Ansys Mechanical, I will first minimize my space claim window, and I can see that I have a green check mark by my geometry, meaning Ansys thinks I have a valid geometry. Then I double click on Model to bring up Ansys Mechanical. When I bring up Mechanical, my truss does not look like it has been brought in correctly, but this is because it comes in an isometric view. If I come down here and click on the Z-axis and orient my truss looking down the Z-axis, it now looks like I had it designed in SpaceClaim. I come over to my project tree, and under Model, I click on Geometry or Look at Geometry, and I have a green check mark by that. I need to be careful with that because right now the materials that have been assigned to all parts of my geometry are structural steel, and several of the members in my model need to be of aluminum. So I need to come here and click on the plus sign to open my geometry, click on the plus sign to open my component 1, and now I see the 5 beams that I created in SpaceClaim. This first beam needs to be made from aluminum, so I click on that, and now I drop down to the details of the beam, and I look at the material assignment, and I see that it is structural steel. I can left click on that box, left click again, and select an aluminum alloy. The square tube was also, or rectangular tube, was also made of aluminum, so I'll click on rectangular tube, come down to material assignment, click on the white box, click again, click on aluminum alloy, and I now have assigned the right materials to my beam members. If this window down here is ever grayed out, what you need to do is exit Ansys completely and come back in. Make sure you do a save before you exit, and when you come back in, this will be ungrayed and will let you change the materials. So I can now come up and minimize the geometry windows again. I can click on materials and see the 2 materials that I entered. Again, I can click on them and see the material properties associated with each of those materials. I can click on cross sections and I can change these cross sections and I can look at them in detail. I can see which beams are made by that particular cross section, and if I needed to change those, I could go back and do so. My connections are taken care of because I made all of these beams merged. So I simply have a green check mark by connections, meaning that all of these have been merged together. So I'm ready to perform a mesh. To do the mesh, I'll click on Mesh, then I'll come up and click on Generate. And Ansys generates the mesh. I can see the cross sections of the materials. Holding down my middle mouse button, I can rotate about particular points. I can see my square tubes and my hollow tubes and my rectangular tubes, and I can see my entire structure and everything there. If the mesh is too fine, or I want to refine the mesh, I simply come to Mesh, click on Mesh, click on Mesh along the top menu bar, then I come over to Sizing and click on Sizing. You can see now I get question marks in my mesh because I need to answer some questions in sizing. So I click on Sizing, and I come and I pick the particular members or member that I want to change the element size for. I will just pick this top beam, and then I can come down to No Selection, click it, click again to apply, and it says I have one edge for my geometry. It tells me my default element size was 0.24922 meters. If I want to refine the mesh, I can, for example, type in a 0.1, enter, then come back up to Update and update the mesh. And when I do that, you can see that my mesh has been updated. I can click on mesh and there are more elements now along this top member. And if I wanted to do that to these other members, I could do the same process and just keep entering sizing controls on mesh. So now I'm ready to go down to static structural. I see there are question marks there. This is where I enter again the boundary conditions and the loads, and there are questions because I haven't entered any of those. So I click on static structural. I come up along the menu bar until I find supports, and I'm going to put a fixed support in this top corner. So you can see now that I'm selecting lines. I want to actually select nodes, so I'll come to the node selector, click on it, come over and select that key point. I need to be careful in saying nodes because nodes would be selected using these element type selectors. Key points or grid points are used selecting this connector. So I click on this key point and now I can come down and click apply and I have one vertex that has a fixed support. I'll now come down to this bottom node or vertex, click on it, and I will come up and click on the displacement support. Click on displacement. I can come here and click apply. Then I will fix the X degree of freedom to be 0, and I will leave the other degrees of freedom free. So I'll hit enter there, and these will remain as free. I can come back up to my structure tree and review my boundary conditions by clicking on the fixed support, and I see this node here is fixed. I click on my displacement and I see that this node down here, the displacement down here, is set with a 0 free free, and I can also see that here with a 0 free free. Now I'm ready to apply my load, so I'll come over to loads and I'll apply a force. So I click on force, I come over and click on this vertex, and I click apply to select that vertex. Now again, I like to enter my force in terms of components and not a vector. So on define by, I click on this white box to vector, get the drop down and change it to components. Now my components in the X direction will be a plus 200 and in the Y direction a minus 1000. And when I hit enter, those will be the loads and I can see my force up here applied and it looks like it should. Now I'm ready to come and tell Ansys the output that I would like. So I click on solution and I come up and I will look at deformation and I want to look at the total deformation. Stress, you can see that there are no items available under stress, and that's because all I have in my model are beams. And so I need to come up to my toolbox and enter in a beam tool. And now that beam tool, when I open it up, it computes all of these stresses already for me. I can also have it add a maximum bending stress, minimum bending stress, a direct stress, and direct stress was already there, so now it's giving me a direct stress 2. If I want to delete that, I hover over it, right click, and come down and click on delete. And it'll ask me, do you want to delete this object? Yes. So now I'm ready to look at my solutions or solve my model. Everything here has lightning bolts, meaning it's ready to be solved. I don't have any question marks. And so it's a good time to come up and save your file. And you can do a file save. And then after you've saved it, you can click on solve. After the solve is complete, you see that you have green check marks by everything all the way up. You can then click on these different items to see your results. There's the direct stress. Here's the combined stress, maximum combined stress. I can come back up here to total deformation and see the total deformation. So that's what you need to do to solve a